So, good afternoon again. Before moving on, I will say something that I have forgotten to say in my welcoming speech this morning, which is that we are very grateful to Cátedra Mir Puig, who has been the sponsor for the coffee break and the lunch. Okay. and now we will have this round table in which the 5 speakers will ask some questions to Alessio Figalli, at least one question each one, and later on we can allow also the students here to ask some questions, because most likely they will be interested in knowing how Alessio has developed his academic career and things like that. Okay, so we will start by Juan Luís Vázquez. So,
Good question.
My question is, come on, siesta time. Mathematics is now very popular in our countries. Like Spain or Italy or Switzerland or China, because of multiple applications and job offers. And some people are worried because we think that a solid, pure mathematical education is still essential in the education of undergraduates and graduates. So there is a balance. What is your opinion about this alternative?
Academic.
Pure and very applied, yeah. Innovation or traditional?
Yeah, I don't know. I don't see that as a real contrast. I think what we see in some countries, especially US and UK a lot also, is that a lot of people can get a very strong mathematical background, very theoretical, and then they can decide, some continue in the academic career, some went to the private job. I think it's good if we have more people who have a strong mathematical background, because it's important for many jobs, and the fact that there are also other directions is also, sometimes maybe students are discouraged to start even mathematics because they think they will not find a job. That's sometimes what I hear from students in Italy. They're like, oh, maybe I start mathematics, I will never find a job later, so maybe I should just go to engineering directly. So maybe this could be also a way to, don't worry, just do mathematics, enjoy, do your best. If you like it, do a PhD. And then if you like the academic career, you continue. If for any reason you prefer to go to the private industry, you can later. So I see this more as a richness also for us, because then maybe more people at least try mathematics, and I think now a lot of jobs actually want mathematicians, just because we are in a society now where you don't need really specific skills, because skills are changing all the time. You more need to be able to think, to have creativity, to be, you need to adapt to new situation, learn new skills all the time. So mathematics is actually extremely good for this. So that's why I think many people now I see this in UK, it's crazy, right? A lot of all PhD students and postdoc in Cambridge get emails almost every week from companies. And many decide, likely for us, to stay in the academic, but some decide to move to the private industry. And that's okay. I think it's good.
now it's time for Xavier Cabré.
Okay, changing topic. Could you please describe briefly the role of the Scuola Normale Superiore di Pisa within the Italian university system, and how important was for you, or has been for your career? And in this direction, do you have any suggestion on how Spain could maximize its chances of having a Fields medalist at some point?
Very good question. Okay, so as Italians, I think we have been very lucky to have the Scuola Normale. So as you know, Scuola Normale was founded by Napoleon. So starting from the French model, and I think as let's say numerology shows that French have been even much more successful than Italians, right, to get the Fields medal. And I think, of course, the fact that they have so many schools that are really done to train new researchers is very good. So in Italy, we have these schools since more than 200 years, and it has inspired a lot of other places in Italy, like Sissa. There are now places in Pavia. There are many of them which are developing. For me, it was extremely good. I went there. You know, it's there is this. It doesn't matter from where you come from. It's not a matter of income. It's not a matter of anything, right? It's just a public competition open to everyone. And then once you're there, you don't have expenses, right? So because maybe for some families, it's not possible to afford to send the kids out in a different city. So you are there, and you get the lodging, you get the food. So I think this is good, right? The state is trying to give at least a chance to everyone. Of course, you know, the numbers are not huge, but this is also because it has a cost, and one cannot make it too large, at least for some countries. But I think the fact that, you know, it's like probability, right? The more people you train with a strong mathematical background, the higher are the chances later to get more and more international prizes. I mean, depends, you know, whatever it is, Fields medal or many other achievements, or even going anyhow to prestigious places across the world. So for me, it was extremely good. I think it's we are lucky that we have this in Italy.
Is it like another university? Is like studying in another university in Italy, or
okay, so the way, maybe since maybe not everyone knows how it works, so Scuola Normale in Pisa is different from École Normale in France, right? So it's very different, the system. First of all, so in France, once you're a student there, you do everything there. So in Pisa, the difference in Scuola Normale is that you're attached to the University of Pisa. So all students are enrolled at the University of Pisa, and we follow the classes like everyone else, with the addition of extra classes at Scuola Normale. So the first year we had one class of mathematics, in one class of analysis, one class of physics. Second year was measure theory and probability and electromagnetism. Third year was algebraic geometry and quantum mechanics. And then fourth and fifth year are very specific on the years. They change. These were the extra courses we had to take. So these were each of them 4 extra hours. Plus, I think what was extremely important. There are 2 things I think that also extremely important. So we learned to do. They gave us a lot of exercises. So sometimes there is this idea that exercises are for engineers, and I think this is a bad thing, because you can learn many theorems, but if you don't, get a bit your dirty, there is no way to really understand how mathematics work. So they were giving us a lot of exercises every week, and they did it. We were 30 scientists, so it was mathematicians, physicists, chemists all together, and every week we were put in couples, and we have 15 exercises for the 30 of us, a list, and each couple was supposed to write well the solution of the exercise was done, and then they say, okay, look at the others, but your job is to write the solution, very clean of this exercise, and this will change every week. And some exercises were a mess. I mean, sometimes we went to PhD students to ask for help, and of Scuola Normale, and they were not able to help us. They're like, we don't know. So, but it's good because you start to learn frustration, which anyhow you will learn eventually. Also the fact that, maybe you're not able to solve a problem, but you keep thinking about it, and maybe 1 week later you get the solution. So also the idea that it's not like you do a problem, either you know how to solve it in 5 minutes or you never know, right? It's a long-term process where you need to go back on and on. So they're already training you in the mindset of a researcher, and also not, which is just, it's a different way, right? It's not that you are trained for everything. And and not being scared. I mean, I think one thing that I notice from most students in Scuola Normale is not only what they teach you, but also that you're not scared to try new things, right? Maybe you will fail many times, but there is nothing wrong with that. And also the cooperation, the fact that you are in groups and you share ideas, you have a doubt, you go to your friend, at the canteen, maybe you speak at lunch, okay, why this thing works, I don't understand. Because mathematics, it takes a lot of time to absorb things. I remember how puzzled we were when they say that the rationals are measured zero. I mean, like, really? I mean, this concept, measured theory, sometimes it's intuitive after, right? But I don't know, at the beginning, the first time you look at it, oh, rationals are measured zero, but they are everywhere. How it's possible? I mean, I don't know. That was extremely rich for me, and I think it made a lot of impact.
Thank you.
Matteo?
Matteo.
Okay, I will maybe continue in the same direction as Xavi, because what I wanted to ask you is the problem of time splitting between hard problems and, say, doable problems, no? In the sense that do you really have to worry if you don't succeed in solving a problem right away? At any level, student, PhD, young researcher, senior researcher. Okay, this is my...
How to balance.
Yes.
Yeah, that's... Okay, I think everyone is very different from person to person, so this is very tricky to give an answer for everyone. So I know some people are very effective by really concentrating on a single problem for very, very long time, because that's the way they absorb, but also the way they function. You know, there are some people who go more by blocks, and some people who are more in the multitasking mode, and I consider myself more in that, where I can switch more easily. And there is no recipe. I mean, we are what we are, and we should not even try to correct too much ourselves. I think everyone has its richness. I mean, I think that the fact that we are different, it will sometimes make big progresses. One could think about someone like Andrew Wiles, who spent 8 years on a problem and then he made it all the way, and it was a huge success for mathematics in the end, all the things he developed in order to solve Fermat's last theorem. And people are very different and still make big advancement. So in my case, I think the point is how you deal with the frustration from not solving the difficult problems. Now, if you're a student, that's where the PhD advisor comes in, right? She should be the person who guides you and tells you, okay, this is difficult, perhaps try to solve this simple case first, or maybe, I think I underestimated this problem, and maybe let's try first this other thing. So, of course, that's the moment where you should be guided, also in the choice, but also through the process of learning how to do research. Then once you are on your own later, you need to find your own balance. So in my case, I have this paper with Guido De Filippis on Mont-Jean-Père, where the first time I heard about the problem, it was 2005, and we solved it almost 2012. So it was 7 years. And in the end, the paper is, 13 pages? So it's not like very long. So the key ideas, there were some key ideas to be found, but we found them really at the end. And but I remember trying many times this problem for several months, and then I had just to give up, and then say, okay, that's life. Failure is part, but I think one thing that I realized is that I learned much more from problems where I failed a lot. If the problem comes too easily, then I don't learn that much. I just solve the problem, and I think I learned much more. So one should always look at the bright side, even of all the times we don't succeed in solving a problem. So maybe I didn't solve many problems. That one I did, but many I didn't. But I learned a lot of things by not solving them. And I think one should always try to get the positive side, that all the things we learn from not, like you said today, right? You try 2 years and then you learn that perhaps you should look for counterexamples. But I don't know, you have to pass through it. So yeah, in my case, I always, the multitasking part always helped me, because then I always had maybe some problems where I really had no clue. Some problems where I had some clue, some problems where I had a bit more clue, and then by moving more things, it was easier.
Somehow it's like with the investment, you have to diversify, no?
The portfolio.
You have to have,
Yeah. Yes, but I think again it's very personal, right? So I wouldn't tell to everyone to do that, because maybe you are overwhelmed and you know, it's the way how you function. If you need time to get into a problem, I'm not sure it's ideal.
We do lots of trick transfer. You learn something in a problem and then you realize, oh my God, I can solve this other problem.
Mm-hmm.
So transferring from branch to branch is very good when you are good at multitasking.
Right, but this comes with experience. So I think this is more, of course, it's very good once you're more senior, because then you are able to see much more, and that's why you can do much more. But I think when you're younger, you still need to get enough knowledge, right? And that's the most difficult moment, I think, right? I mean, is where you are more fragile, because you still need to get confident about yourself. And one thing important that I think is that one shouldn't take failure personally. You know, there is adaptive sometimes. Oh, I didn't succeed in that. Maybe I'm stupid. Maybe I'm not done for this. I don't know. If one has a passion, one should try to follow it. And remember also that many problems are difficult. So if you don't succeed, you know, it's also because the problem is difficult. It's not maybe you you are not able. No one before did it. So it means something. You know, one has to learn how to deal with that. Of course, once you're more advanced, the transfer is much easier, right? That's also why you look at the number of papers, I think, and the more you go advanced in the career, the easier it is to do more paper, because you have more collaborators, but also you have more experience on how to put things together. So that's, of course, something.
Also, can I say one more thing about this?
Yes.
So I remember when I was a PhD student that Xavier Cabré told me or us in this direction, like okay, you have to keep doing things, so do problems that look real. I mean, it looks realistic that you can do them, but always keep in mind like very difficult problems. I mean, like don't say like I will not try this because it's too difficult. Just okay, maybe don't spend all your time on that, because it could be a bit of a suicide. But if you keep doing things, but always keep like a very difficult problem in mind, and then at some point you might solve it actually, or you can like the more you think about a problem, I mean, having it there, it's very useful. And
Yeah, it's good to have.
yeah, and then actually at the end you end up solving them, some of them.
Mhm.
Some of them, yeah,
Oh.
of course, because
Most percentage, but still,
Yeah,
but
but
still is good. One is worth a lot.
yeah, I mean, even if you have like 3 of these problems and then after 10 years you solve one, it is like, oh, super good. I mean, I mean, but this is I think it was a very good advice that like, okay, don't suicide with like saying from the very beginning, no, I will do this, which is very, very difficult, but don't say I will not try to do this because it's too difficult. So
Yeah, you need.
this was useful for me, as you said. I mean,
Yeah,
depends on the person, but I think that was a very
yeah, it's a very good advice.
Yeah,
The importance of the advisor, right?
agree.
I think that students must learn from Alessio, from this sentence. I learn more from problems where I fail a lot. Okay? Sometimes you ask for the solution of the problem, and it's good that you think by your own. Perhaps.
Yes, it's necessary, otherwise you don't learn.
Yeah, the solution given by someone else is not the same. You forget it. If you spend a lot of time, and maybe eventually someone give you the solution, it's completely different, because then you remember, right, why you didn't succeed and what was. So even when one gives you the solution first, you need to pass through the thinking a lot over the problem. That's the only way to learn, really.
Perhaps Xavier can carry on.
Okay. So, okay, I actually have like 2 questions in mind. I have to choose one. So, okay, let's change a bit. And
Okay.
and
So they
then-
prepare themselves. I didn't. So.
Yes. Yes. So, one difference. So, like, this is about like research evaluation, if you want. Okay. So,
Okay.
and which I think it's quite different if in Spain, Italy, and other countries compared to US, Germany, Switzerland, right? I mean, I guess you've been in committees in both kind of countries in a sense.
Yeah.
So I would say, to summarize, that in Spain and Italy, they ask you for, like, the questions are like, how many papers do you have? Or how many, in Italy, how many citations do you have, for example? No? Things like this are the kind of questions that a committee wants to look at. And then in the US, for example, or even in Germany or Switzerland, it's like, okay, what have you done? No, I mean, and then you look at recommendation letters, for example. They are very important. That we don't have it. I mean, in the system or in the hiring process in Spain or Italy, you will never have recommendation letters. While in the US or in Germany, they are like among the most important things in the application process, right? They are like application letters, recommendation letters that the applicant does not see. So it's really like someone who's writing the recommendation letters. They also look like what is the best things that the best papers you've done. I mean, and not so much like how many. No, I mean, which is, and then my question is, I think that I guess both systems have a bit of advantages and disadvantages. So I wanted to ask you, because the Spanish and Italian are made so that they look more. I mean, they are more objective in a sense. I mean, no one can complain, in a sense, because it's a.
Maybe it was numerology.
Exactly. And then the other ones, I guess you trust more on the advice of the hiring committee, but then you can really see what have you done, if it's important. I mean, so my question is, what do you think about this dichotomy, if both of them have good advantages and disadvantages?
Mm-hmm. Okay, I think that's very tricky. No, that's extremely tricky. So why? Okay, let me just take Italy as an example, because it's the system I know better, and but I guess so. In Italy, what is the procedure now, right? So even to apply for positions now, you need to pass what are called the mediane, right? Which there are minimal numbers and depends on the area. So for algebra, it's different from PDE, which is different from mathematical physics and so on. Okay, and if you don't pass these numbers, which is number related to number of publication, number of citations, and whatever, maybe H index, I think these are the three, you are not eligible to apply. I mean, the committee could still overrule it based on something, but it's very difficult. And then you can apply to get the habilitation and then to apply for a competition. Okay, now where is the problem, right? So I think in Italy we're trying to do this to make it, as you say, more objective, and probably the same in Spain is the same, because you say there is a minimal quality check. Some numerology could make sense in a very weak way, in the sense that probably, I don't know, sometimes there are extreme cases, but I don't think that in the end they're so useful. I mean, in the sense that, they just cut some tails in the number of people who can apply, but
then the committee will also look at these numbers, probably, or not?
At least for in Italy, this is needed to pass the habilitation, so you're not able to apply. But then once you are in, it means you pass these numbers, right? Which is a very bizarre way of doing it, because it's based on a mediana. What does it mean? It means you look at the numbers obtained by more than 50% of the professor in that category, and this is the number you have to pass, which is completely crazy, because I mean, you understand that the mediana, the better the quality, the more it goes up, and then it's more and more difficult to get in, because so you don't want to hire two good people, because then the mediana is going to explode and no one will pass the bar anymore. I don't know, it's a bit crazy that, but okay, independently of how they do it in Italy, my impression is that if people accept to do things well, and one has to understand how to avoid, in the committee, let's say, situations where there is no control and you just hire whoever you want, let's say, the letter system helps. So I truly think, because if I'm doing a committee where it's only for analysts and stuff, it's easier. But if I have a position in a whole department, like now in Switzerland, we always have position open mathematics, and then we see.
Usually in the US is also like that. No? Most openings are for
math, and then you look on quality, and then you decide. Of course, maybe you have an idea. You would like to have as a preference, you want someone in that field, but if you have a super top person in someone else, you don't want to close yourself this opportunity. And then there are two ways. So of course there is this idea of looking at publications, right? So I look and say, okay, where does this person publish? I think this is also tricky because you look, first of all, I don't like the idea that Princeton is deciding for the hiring of all the world, right? Because Annals of Math is decided in Princeton, right? We are putting our future in the hands of just another department or committee or editorial board, which of course is a measure, but we need to also to be able to judge ourselves. I mean, we a bit. So the publications are important, but you know, it's nice also to look at what is inside a publication, because maybe there are top papers. I mean, you know, the Giorgi paper was published in Rendiconti Torino. Who knows Rendiconti Torino?
Salsa said, I was with you, his Rivista di Cazzo.
Okay, I will not translate. But,
I will not translate.
Yeah, I think many people understood it. The Cosina. Yeah, but you know, and but everyone knows the impact. Now we will measure that paper based on the journal or what it tests, right? So I think we need, and at the same there have been examples. So if I think of some papers of Felix Otto on gradient flows, it's communication PDEs, and it has revolutionized the gradient flow communities. So what I mean, sometimes we need to be above just the journals. This being said, the letters are very important, but I think there is also a reason, right? Because within the mathematics, even if you look how many papers a journal publish in some area is different from a different area. So if I judge, you know, numeric analysis, it's impossible to get a paper in Annals, and while it's much more normal in algebra. But maybe I have a top numeric analysis applied, so I cannot just look at the journals. I need to understand the impact of what it's doing. And the letters, if you choose them wisely, a bit across, you know, who you look, who are the experts, you get a sense, because then the people will. You need to learn how to read through them, but they give a lot of information. So I like the letter system. I think you cannot overdo it, right? So because it's a lot of work. So maybe the good thing is like you do first a short list, and then you start to ask letters for the shortlisted people, maybe rather than asking letters for all the candidates, which it's a huge amount of work. I think, you know, but I personally like the letter system, so I would introduce it and reduce the bureaucracy and give more trust also to the colleagues. I think if we work well, we can do a good job.
It's interesting discussion. I think I understood your point. So essentially, you are not against basic numerology to go from 500 candidates to 25, but then when you get your 25. Somebody has to read it.
No, I think yeah. I mean, maybe numerology for me is more from 500 to 200. Let's say. I mean, really to remove the last bulk. But then after you need ready to look yourself. But what I'm saying is that I think you can get a sense in each area. You know, if you're in a committee, you could say you need a bunch of experts. I don't know, when we hire in Zurich, we are usually 14 in hiring committee, so we try to cover a bit of all the spectrum, and then you get down quickly, right, to a smaller number. But then you need informations. I mean, there is no way I can really compare apples to oranges. And
can I say one more thing? That with the numerology, for example, the one was FANECA, there's a Spanish accreditation system. For example, I checked, like you check Peter Scholze.
He will not pass.
He will not, by far, he will not pass even to be a permanent professor, and he's a Fields medalist, right? I mean, there are many Fields medalists that...
Yeah, Gombachao is the same.
Because of the teaching?
No,
the publication.
No, even the research numbers.
The research numbers.
Number of papers. I mean, he got the Fields medal, maybe he has like 12 papers.
Yeah.
And number of citations. He doesn't have so many citations. I mean... So
Langland program doesn't.
But then...
when you work in something very hard, sometimes you have less citations. So
you have to be very careful with the numeral. I mean, from 500 to 25, you would miss. Peter Scholze if he applied, but probably not.
Yeah, but it's not only one. I think.
The impression that the letter system also needs some education.
Needs a lot.
Yes.
From the professors and from the system.
Yes.
And in the US, I thought that I had the impression they were used to it and trained, and they would know how to make these letters so that they are useful. And I don't know if we have that. We can accomplish it, but not immediately either.
I think one thing that I like about the US, I can say. So okay, the letter you need to learn because you need to learn how to read them and how to write them. What are the informations and be careful how you write, right? But also one thing that I like in US, which is rather clean, is in everything there are there are rules which help everyone, like conflict of interest. If there is a conflict of interest, you have to declare, and maybe there is a conflict of interest, you leave the room in this moment where we declare this. It helps, right? There are clear rules which are not personal, and they're applied blindly. But and you cannot say some things because, I mean, just because they have these rules, and I think it simplifies, right? Because if I'm in a committee and I feel, I don't know, that a colleague of mine is doing something which is a bit against a conflict of interest, because maybe he's a very close collaborator and he's arguing very in favor, I don't want to be the person who start to say, hey, wait, you cannot talk about this person, because of course we are colleagues. I don't want. But if there is a clear rule, justice applied. So one thing which is good, which is original in Switzerland, I never experienced that. So I'm not saying, but it's curious. The head of the committee is not from the department who is hiring in our committee. So if we are hiring mathematics, the head is from a different department. And he's the one who enforces the rules, like he enforces the conflict of interest, influence everything. So he's the person like just supervising that everything is happening in a clean and transparent way. And that's much easier because this person doesn't know anyone. So he's the person who can say, sorry, you have to leave the room now because we are talking about your former PhD student. So if you have something to say, please say it, but then leave the room during the discussion. Stuff like that. It's, I don't know, I'm not saying it's necessarily a solution, but it's an interesting way of operating.
Yeah, I would like to go a bit back to the first question of Juan Luis, but I think it's maybe related to because it's the different idiosyncrasy between some countries and some other countries. So in United States, you mentioned in Switzerland, I would say the majority of people who finish their PhD in mathematics go to work in the industry.
Mm-hmm.
It's the majority, and
Yes.
and they are excellent. Like in the ATH, they are super top students, and no one sees this. So they do the PhD in mathematics, and no one sees this as a failure.
Mm-hmm.
It's perfectly normal and perfectly fine, and they do very good careers, right? And maybe in Spain, maybe this has started to change, but in Italy and Spain, it was not like that. People take or used to take it a bit as a failure of the academic career. So how can the university maybe benefit, or the prestige of mathematics in society benefit, if more strong PhD students went to the society and interacted more? I don't know.
Yeah. So there are many things, right? So on the one end, I see in Italy that some people will tell, again, but maybe there are a lot of similarity, that some people say, okay, if the reason why you see it a failure is that it's not, you don't get value from the PhD. Like you go to apply for a position in some companies, they don't care that you have a PhD. I mean, you could have got the same job if you had done it at the end of the master. That's what happens. So in many companies in Italy, the fact that you have this bonus, okay, you have a title, but we are gonna hire you at the same level as anyone coming out of university. So that's also why you could take that as a failure personally, because you're like, okay, why did I do the PhD for 3 years if there is no recognition? While, in US, you're a doctor, which means something. I mean, usually you get a higher paid job, more specialized. So I think there is the failure, you feel it also personally just because you don't see the benefit of what you're doing. At the level of the society, the reality is that there is a benefit, right? Because if you have been trained to think critically for so many years, I mean, you can bring real skills in many jobs. And I think that's something that we will see it more and more, I think, in the society. The problem is that mathematicians were not so many. I don't know the numbers here, but if you think how many people finish the degree in mathematics every year in Italy, is minimal. I mean, compared to the number of people who finish a degree every year, I mean, the number of students coming out of university. But mathematics is getting recognition. I think also we need that, because the more the society value the mathematics, I think the more will benefit us as universities in terms of funding and respect. One thing that sometimes I say, one strength that we have us as mathematicians in ETH, one advantage is that we are a polytechnic school who teach for every department. And here is the same, but some like University of Zurich, you don't, right?
Yes.
And on the one hand, you could say is an advantage. I don't have to teach to other department. Is maybe less is different teaching. On the other hand, it gives you leverage and gives you value because any other department see the values of mathematicians, and this goes out, right? So the students come out of ETH, even engineers, and they say, oh, but people who hire them know that they have a good mathematical background because they were taught ETH by mathematicians at ETH. So it's all a circle. And the more I think, good mathematicians go to the industry and everything, the more the society can see the point, and the more one can argue, we need funding, we need money for research, so I think we shouldn't see the industry as our enemy. We should see more as something that we could benefit from. Also because then we can start to have maybe joint PhDs. Like in ETH also we have joint PhD sometimes with Google, where Google puts the money and maybe...
Here it's starting to happen. Yeah.
Well,
Yeah.
because all this big data and all this biology, genome, all this is helping.
I think
It's helping us, right?
it's helping us, right? Even in every kind of and mathematics is gonna benefit from that. So I think it's a good moment for mathematics and mathematicians, independently of then whatever paths people take. It's a good moment.
Yeah, but I think that we have to stress, we have discussed that over lunch, that mathematics adds to these people who want to industry the ability to solve problems, problem solving, and also the ability of being creative in difficult situations. Don't be afraid of a problem, just solve it. And then this gives you critical thinking.
Yeah,
That's what they
that's-
need. And we have to tell society that in the world of algorithms, these three things, problem solving, not be afraid of this creative and the critical thinking is very important. A doctor has gone through the experience of having to solve a problem or two or three.
Yes.
After doing a PhD, a student can think what is the best strategy for its future. His future is what is better: staying around and try to get a permanent position in the same place where you have studied, or going abroad, which can be seen as a high risk or high gain strategy. Okay, and in this sense, how important has been for your success to move to Austin?
Okay. So the answer would be, I think, okay, for my success, it has been fundamental, but let's say in general for mathematics, I'm personally against being in the same place. So I don't think it's good. I mean, even in the spirit of, I think it's even good if very good people then come back. I mean, I think, we have a life, and maybe we are born in a city and we would like to go back in the city eventually. It's perfectly fine. But I think in the spirit of research, the fact that one goes around, maybe for PhD, postdocs, maybe one job at the beginning, or even not, but at least these 6 years between PhD and postdocs where it's abroad and come back, this is extremely good. It's good for everyone because you bring other skills, you learn other stuff. So if I think about myself as a mathematician, I studied in Italy and learned a lot about all the school of the Giorgi, so calculus of variation, geometry measure theory. Then I moved to France. I benefited a lot in France. I learned many, many things during that 3 years. But then, and that's where in that period it was an interplay between optimal transport and isoperimetric inequalities. But then I moved to Austin, and that's also when I solved a few years later the problem of Monge-Ampere. I mean, I had Luís Caffarelli in next office. Even if we never discussed that problem in detail, just breathe the same air. I mean, and you listen. No, but you're there. You listen to the talk of the people who are invited by Luís. You know what mathematics is done. I was attending some of his classes. When he was teaching PhD classes, I will go and sit. So that's something I could never have done. So I'm a product of the fact that I traveled. Now, there can be personal constraints sometimes, and that's it. But ideally, whenever possible, I would say, do it. go out, see what other people do in other departments, learn as much as you can, and then I think the strategy of Spain, and I think it should be the same for Italy, is to get the best people, the best Spanish people. Of course, also people from abroad, but at least all the best Spanish people, try to get them back. That's of course important. I mean, we don't want to lose them, but I think going out is part of the process. I mean, that's how also Spanish mathematics can grow, by this flow in and out.
I think that the speakers have more questions, but I will like the students, especially the students here, if they can ask a question for Alessio.
Hi. I'm asking for some career advice for PhD students, for example. What do you think? Okay. What do you think about cooperations, like in writing papers with other people, writing many papers with many different people, instead of maybe concentrating more into single author papers? For me, it's I think personally that it's very wonderful to work with many people, and I mean, you learn more. Also, social, it's more satisfying. But there have been some people that telling me, with this you split the credit. Like it's not only your paper; it's a paper of you and other.
For a PhD student or in general?
Okay, well, I'm asking as a PhD student, but maybe the question can.
This can change if you are a PhD applying to the PhD period or the senior.
Okay, so let's
General.
ask the both questions.
Okay.
Yeah. So what's your opinion about cooperations? So thanks.
Yeah, so I think one needs, okay, again, it's very personal, because I think some people just like to work themselves, and some people maybe are very collaborative. And one is also a bit the advisor who can figure this out, so also speaking to the person. In my case, I always wanted my students in general to try something on their own. So at least, usually the first paper or one paper at some moment, I wanted them, okay, from the beginning to the end, do it by yourself. So of course, meeting with them and guiding through the process, but something where you really create that. And because some people don't need it. Right? Some people, they can do everything, and even just all collaborative, and there is no problem because they are very good anyhow, and they manage to do very well also later. But I just don't want a person to think, okay, I can only do it if I'm in collaboration. I don't know. It's just a feeling where it's a personal thing. I don't know. Maybe you feel it as a weakness for yourself. Maybe some people don't. They don't care, and that's very good. I don't know. My advice was, I always wanted that. I think one problem is your problem, right? And is your baby, your creature, bring it from beginning to the end. But then I encourage also collaboration, because I think mathematics is also fun because we discuss it. I mean, I have a lot of collaborators, and that's how I most enjoy doing mathematics. So in my career, I don't know, maybe less than 10% of my papers are by myself. I have some, and the one, in my case, the most one-sided for prize were in collaboration. So, and I think I'm not the only case, if one thinks. So, of course, I think people in the end, you average out, right? I mean, if you, with this person you did this result, with this person you did this result, this person did the result, I mean, it's not, you share, but in some sense, I don't know, I don't feel it as a 50-50. I think it's more, both people get a good credit from it. It's not that you divide by 2. I think still the percentage is more than the half. So, and people will value. I think you create your path. So, I don't know. I advise at some moment to try one problem alone. Just even if later on at some moment you say, okay, this problem I always wanted to do it. Let me keep it as my baby. I do it on my side. I take my time. It's not necessary. But that's my opinion. But probably Xavi has.
No, I would like to relate this also what we were talking before about difficult problems. These so difficult problems. For me, I take like I almost consider that some problems which are difficult, I will only be able to solve them talking to people that at the end will be collaborating with somebody. It is too tough that I cannot do it, or even Alessio Figalli alone cannot do it. But this is very good because it gives you also, it takes out pressure.
Yes.
Takes out pressure and gives optimism. Because I can go to talk to Alessio Figalli, but I can go to talk to Luís or to Cédric Villani or whomever. So there are chances. If I'm patient and I have like 10 years to solve it or more, I feel okay. And I don't feel bad if I'm not able to solve it, because from the beginning I almost know that I cannot solve it alone. I need to talk to people because my brain is just my brain, and it needs to be, it needs to work a little different.
Yeah.
That
Stimulation.
just another person that has a brain different will produce that on my brain, say, and the conversation. So, but I think that for a PhD student, it's good to make at least one paper by himself for his confidence and also for what a PhD means, say.
Yeah.
I think.
Yeah. Let's say will not be compromised. I think now many people just do it also in collaboration. But as a personal advice, it doesn't have to be a super difficult problem. But I always wonder this case how it works. Let me try by myself. You know that you go from the beginning to the end. Actually, just one last story. I remember that my very first paper. I remember because my very first paper. I was in Lyon, and I was a young student, and Luigi Ambrosio sent me to Lyon for one semester. And then there was Albert Fati, who was my office neighbor, and one day he came. So we were discussing about optimal transport with him, and then one day he told me, "Oh, there is this paper which is extremely interesting, which is combining a bit of WCAM theory and big optimal transport, and give it a look." And then he made me read the paper, and I say. He told me, "Oh, it will be very good if you did so this was a result about some optimal transport problem on compact manifolds." And then he said, "You should do the same thing on non-compact manifolds." And then I look at him and I was like, "But this is very easy. I mean, I just need to change." And then he looks, "Yes, and that's why it's the right problem for you." So, I felt at the moment like. I don't know how to take it. It looks not very. It doesn't look a big compliment to me. So I went back, but then I was a student, so I said, "Okay, Albert tells me this. Go back, office, start." I learned so much by trying to put every detail there. I mean, the idea was clear, but the details were nightmare. I mean, and he was right. It was the right problem for me. Because it was a moment where I needed to learn how to write mathematics to get some confidence. And so it was just try to generalize, but good luck with that. You have to take this, but then you will have to read other literature because these theorems will not apply. And you have to really understand there will be a lot of compactness properties that were not obvious. And at the end, it's my first paper. I published in a simple journal, nothing fancy, but it gave me the confidence that I could bring it all the way to the end. It was the right problem for me at that moment. I learned a lot. So sometimes, we don't need that much, but we need this moment of in our life. It was very good for me. I mean, I learned a lot from Albert. This was one advice. Second advice he gave me, which was also very interesting, he told me that. So he said, "Okay, now that you finish write the paper," I say, "Oh, it's done." And he say, "Very well. Now take it. You put it in your drawer, you close your drawer for 3 months, you take it back, and you read it again. If you understand it, you can submit it." And it was very right, because when we write a paper, I learned, I never do 3 months and then with collaboration is different, but if I am by myself or maybe with a student, usually I take it 1 month and then I read it again. And it's true, when you just write it, everything is clear because you just wrote it. But if you read 1 month again, you're like, what did I have in mind here? What did I mean? And we do this. And this was another very interesting advice that he gave to me. I think he's right. That's why some papers are not very clear when we try to read them, papers from other people. Not because they didn't put effort in it, just because they submitted right after they just wrote it. And then it was too clear to them what they had in mind, but not for the others. Juan Luis.
Just adding to these two comments that I agree with them, one of them that during the PhD you have to show what is your work, what are you contributing yourself, and then after PhD you have to collaborate with people because you enjoy life. And then there is something else I wanted to add. There was a trend in my whole life. I went through different periods. In one of them, there was a trend in Europe towards sending the younger people when they finished the PhD to different laboratories to stay for 6 months and write a paper. So a typical idea of these people in Europe was that this young guy who was very good wrote 6 papers in 3 years with 6 different people in 6 different laboratories. This was a way of producing baseless numerology. Terrible. A poor guy in 6 months was not able to understand everything. Next 6 months was in a different place with different people, with a different language, beginning a new job. So collaboration has a caveat that we use when you are old enough. If the number of people who sign the paper is 3 or more, one of them doesn't know what it says.
Any other people from the public or especially students, please?
No pressure.
Don't be shy. No? Sure? So perhaps, yeah.
Well, he's suggesting.
Yes, so I will ask, but actually he asked. So
No, it's your question.
yeah, I said. But
He
so
wrote the question.
I wrote the question a few days ago. Now he's suggesting, but I had another one in mind. But okay.
You can do both, and then
No, it's okay.
then I choose.
No. So the question that so it would be, you finish your master, and then you have to choose where to do your PhD, right?
Mhm.
And then there is a balance. I mean, there are like 3 things that you should choose. Like, and the question is, what should be more important in the decision? Like the topic, like the advisor, or the university, right? I mean, because if you focus on a very narrow topic, then there is not so much choice for the other 2. And then if you focus already on maybe you have to focus more on the person, and then you want someone who is very good, but then you choose a bit less the advisor, or maybe you just can move to another university and then choose that you are in a very good university and see what you can do there. I mean, what is the balance that you think is better?
I think so. It matters a lot. I think how the master went, in the sense that but what I mean is that if you had a good master on a topic that you liked, then you already have some kind of directional research. And this is now a big advantage, I think, especially if you stay in Europe or anyhow in countries where the PhD is only 3 years. Because like in Italy, most of the grants are 3 years, France is 3 years. So
Germany and Switzerland is not. England, Spain are more like
England is 3.5.
Okay.
It's a very tricky number, right? So what I mean is that I think mathematics is growing a lot, and it takes time sometimes to enter in a problem. So if it's 3 years, let's say, but now we are in an international system where anyhow you apply for postdocs almost 1 year before the end of the PhD, then it means that really you have 2 years to do research. And that's very short for everyone, right? So if you already the master, you already had that subject that you liked, and you can kind of really enter immediately, then it's different, right? Then you can say, oh, I would like to stay here, or maybe to work with some person which is in the same field as my master advisor, because whatever reason. and then I can continue because I'm already well trained, already spent maybe 1 full year to study a bit of literature. If instead I change, one advice, I mean, it's good if you have at least 4 years. So, you know, I think that some countries have disadvantage over the others because they give you longer PhD fellowships. In particular, even better if you have no clue what you want to do, is like the US system in that, because you give you like usually 5 years. The first year, 1 or 2 are qualifying period, where for Europeans means that most likely you're often ready for most of them, and maybe you just need to prepare a few of them. But then you have the time to look for advisor inside the university, right? You arrive, you don't have an advisor yet. So I think it's very personal in that respect, and everyone has a solution. The advisor is very important, of course. One thing that you can get a sense from is the track record. Of course, sometimes it's not a good measure because I think in your case, you had a fantastic advisor and they were your first students, right?
No.
Or not many, but not many before, right? 4 or 5. So, there was a very good track record, but for them. But let's say if you look at the numerology, there are people who had many more, but you were fantastic to them. I don't know how to. I mean, the result is clear.
Yes.
No, but I don't know. But there are people who have 20, 30, and then the what I mean is that it's tricky, right? That part of the track record, how you really choose. Of course, some people that just have a lot, but also if you have too many, it's not good either, right? You are having a period where an advisor has 5 at the same time. Maybe he doesn't have too much time for you. So I don't. In my case, I was lucky. I don't know. I think I was very lucky between Luigi and Cedric. Cedric at that moment had 2 students. Luigi more or less the same. So they were a very low period. And
then can I ask? Okay, it's time.
Yes.
yeah, what was the other one?
My other question, very quickly, is that in Italy you do, because it reminds me like what you said before, that in the Scuola Normale you did a lot of exercises. So I want to point out also for people, because usually people don't know. So in Italy, for example, you do a lot of oral exams, and then the written exams are all like basically theory, no, also.
Mm-hmm.
And then here is quite different. Here we never do an oral exam at like an undergrad class, no? You're in 3rd year of mathematics. It will never happen that the final exam for Calculus 3 is oral exam there, right?
Yeah.
And in Italy, this is very typical. While here, most of it is like exercises, which I think is good. And then some theory that you have to prove a theorem that you did in class or something like that. So my question was, what can you say very quickly about the oral exam system versus only written, and then also like more exercises versus not so many? I don't know.
Well, that's tricky. In the sense, I think it's very good for students because you learn a lot as a student to have both oral and written, like in Italy. But it's a huge work for professors, and I'm not sure I want to to suggest that now that I am on the other side. I mean, I think it's good to present stuff. So I think having a bit of presentation, giving some oral is not bad, but. For sure, I don't know. Only oral is not good, right? I think written is very important because really that's where you can test more the skills. I don't know. I think anyhow, Spain is doing very well now. So in terms of people who are coming, we see it internationally. I think Spain is growing a lot, and I think it's the same in many other countries. So I think it's good for Italian students that they have this dynamic with oral and written exam. They don't understand how much work there is behind, because I don't know, as a student I didn't realize that, right? I mean, I just thought normal that professor will be there to write the exam and re-prepare another exam and listen for days to us in front of a blackboard, and it's a huge amount of work, and we're extremely lucky as Italian students from them. But even just preparing a written exam is a huge amount of work for all of us. And you only realize when you go to the other side of the barrier. So students should be more aware.
Joaquim experienced both systems, no?
All right, Joaquim was also in Italy. How? Any comment?
For the students, it say, at least my impression as a student is that the old professors did in Italy did the exam very quickly. Like I remember one exam that I was very frustrated because I was starting to answer, and just by my attitude, they knew that the answer was right, and they made another question until I failed. But this was a binary search. It was 10 minutes, and I got the maximal.
Great.
But great. But it was. But
Yeah, because
I
they don't
only
have time,
answered
right?
wrongly one question. So for me, I thought it was going the last one, and was wrong. So all the so it can be because you can also see more things in the oral exam, right?
You can see much more, of
when
course.
you talk to people.
Okay, thank you all for these questions, and thank you, Alessio, for the answer.